Webb's ability to study galaxy mergers has opened new windows onto cosmic history. When two galaxies collide, they send shockwaves of gas and dust flying across space. These merging galaxies can trigger intense star formation as clouds compress and collapse. Webb's infrared eyes can see through the dust, revealing hidden starbursts. Bill Nye says watching galaxies merge is like seeing cosmic fireworks in slow motion. Each spark tells a story of creation at the farthest reaches of space. In some merging systems, Webb found supermassive black holes spiraling toward each other. These cosmic giants twist and distort space-time as they draw nearer. As they merge, they may emit gravitational waves, ripples in the fabric of space itself. Future observatories will use this knowledge to listen to cosmic mergers directly. Webb's images of galactic winds are also groundbreaking. These winds blow gas away from galactic centers, affecting future star formation. Bill Nye explains that these winds can be galaxy builders or despots, depending on strength. Too much wind, and star birth is stifled. Just enough, and it can kindle new life. Using Webb, scientists measured dust temperature within galaxies. This temperature influences how stars and planets form. They discovered pockets of colder dust than expected in young galaxies. This could change our view on how fast stars first appeared. Bill Nye points out that these cold cores might be the seeds of galaxies. Studying them is like uncovering the roots of the cosmic tree. Webb's infrared sensitivity allows it to find quasars, bright cores around supermassive black holes. Quasars shine so brightly they can outshine whole galaxies. Some of these quasars existed when the universe was less than 1 billion years old. This shows that black holes can grow very quickly in cosmic terms. Bill Nye finds this amazing, giant black holes forming rapidly in a young universe. It challenges our theories on how fast cosmic structures can evolve. Webb also studies cosmic filaments, the web-like structure of matter in space. These filaments connect galaxy clusters like threads in a cosmic tapestry. Infrared light lets Webb map cooler, fainter parts of the filaments. These parts would otherwise remain invisible. Bill Nye compares this to drawing the skeleton of the universe. We are seeing the cosmic framework that holds everything together. In one study, Webb observed a lensed galaxy, magnified by a closer massive galaxy. This gravitational lensing acts like a natural telescope. The result? Very detailed views of tiny galaxies billions of light-years away. Webb's images revealed star-forming regions in unprecedented detail. Bill Nye describes gravitational lensing as a cosmic gift. It lets us study the distant universe much clearer than before. Webb also captured images of brown dwarfs, objects between stars and planets. They are too big to be planets but too small to sustain nuclear fusion like stars. Their skies glow with dim infrared light, perfect for Webb's sensors. This helps us understand how these failed stars form and cool over time. Bill Nye says brown dwarfs are cosmic laboratories. They teach us about atmospheres, temperatures, and chemistry in other worlds. Some brown dwarfs even have weather systems, like clouds of iron or sand. Webb can detect these changing patterns in infrared observations. In one case, scientists used Webb to watch dust storms on a brown dwarf. This is the first time we've seen weather outside our solar system. Bill Nye loves this. It makes the cosmos feel more familiar and alive. Even distant objects have dynamic, changing climates. Webb's study of comets in other solar systems is also groundbreaking. By spotting icy comets, we learn about how planetary systems are built. Bill Nye notes that comets carry water and organic molecules, possible seeds of life. These molecules ride comets through space, delivering chemistry across the galaxy. Detecting these comets helps us compare with our own Oort cloud and Kuiper belt. Webb shows that such icy bodies are probably common in other systems too. Webb's infrared imaging also reveals rings around distant planets. In one observation, Webb found a dust ring around a young star. This ring may be the sign of planet formation in action. Dust collects into bigger bodies, building planets over millions of years. Bill Nye says it's like watching a planetary system in the womb. This gives insight into how our own planets, including Earth, came to be. Another amazing use of Webb is studying intergalactic gas, the material between galaxies. This gas shapes how galaxies grow and interact. Infrared light reveals the temperature and movement of this gas. Scientists discovered pockets of surprisingly warm gas in galaxy clusters. Bill Nye explains that warm gas can slow galaxy formation. It acts like a cosmic traffic jam, delaying new stars. Webb's instruments are also sensitive enough to detect magnetic fields in distant space. These fields guide dust and gas, influencing star and planet formation. Mapping these fields helps us understand why some regions create stars while others don't. Bill Nye calls it seeing the invisible architects of the universe. Webb's observations of planetary nebulae are spectacular. These are colorful shells of gas expelled by dying stars. Infrared reveals hidden structures within the nebulae, invisible in visible light. Some show intricate filaments and symmetric patterns. Bill Nye says that these are the beautiful ends of stellar lives. They are cosmic artworks formed as stars return their material to space. Webb also helps monitor supernova remnants, the aftermath of stellar explosions. It can track how the debris moves and cools over time. This teaches us about how new elements like iron and gold scatter through space. Bill Nye says every element in our bodies came from ancient supernovae. By studying remnants, we learn about the cycle of stellar death and rebirth. This cycle powers chemical evolution across the galaxy. Webb observed a planet in the making around a young star. This protoplanet doesn't hold full shape yet, but its dusty cocoon is visible. Bill Nye compares this to catching a planet in its teenage phase. We're seeing early stages of world-making in action. Some of Webb's most surprising findings involve unexpected structures in galaxy outskirts. These may be remnants of smaller galaxies torn apart by larger systems. Bill Nye says it's like finding fossils of galaxies in space. They hold clues about past collisions and mergers. Webb's deep field surveys captured tiny nearby galaxies too. These small galaxies help us understand dark matter distribution. Through them, scientists test theories of cosmic growth on small scales. Bill Nye notes that even small galaxies play big roles in cosmic evolution. Webb also helped map stellar streams, rivers of stars torn from galaxies. These streams stretch across space, showing how gravity pulls matter apart. Understanding streams helps reconstruct the history of galaxy formation. Bill Nye says it's like unraveling cosmic crime scenes, who did what and when. The telescope also studies cosmic dawn, the era when first stars turned on. Webb looks for small, faint galaxies lit by newborn stars. So far, Webb has found dozens of these cosmic newborns. Bill Nye says we're witnessing the birth of the first lights in the universe. This era is just after the cosmic dark ages, when no stars had formed yet. Webb helps close the gap between dark age and visible universe. Another area Webb studies, globular clusters, dense groups of old stars. These clusters orbit galaxies and are among the oldest objects we can observe. Infrared light helps Webb peer through dust to see the cluster's heart. Scientists use this to measure ages and chemical makeup of stars. Bill Nye says globular clusters are like cosmic time capsules. They preserve the chemical record of the early universe. Webb's data also aids in studying fast radio bursts, mysterious signals from space. Infrared images can sometimes find objects at burst locations. This helps narrow down what could be causing these signals. Bill Nye finds the mystery exciting. It's like detective work in space. Webb also supports the search for SETI efforts, signs of intelligent life. It can scan exoplanets for unusual chemicals or light patterns. Bill Nye cautions that this is just the start. But even ruling out possibilities is valuable. Each observation of a planet's atmospheric makeup brings us closer to understanding life's potential.